All right, so hello everyone. My name is Isaac Tete, and today I'll be walking you through the concept and construction of an 8-to-1 multiplexer, also known as a data selector. Right, so someone will ask, what is a multiplexer? So a multiplexer is a combinational logic circuit that selects one input from several and forces it to the output. It's commonly used in data routing, control unit, communication systems, and even CPU design, where choosing between data sources is essential. So let's begin by understanding what an 8-to-1 multiplexer is. So an 8-to-1 multiplexer has 8 input lines labeled from I0 to I7. Now to choose one of these inputs, we use 3 select lines, that's the S2, S1, and S0. These select lines act like the address that point to a specific input. The multiplexer uses these select signals to route one of the 8 inputs to the single output line Y. Now, since we need to choose among 8 inputs, we require 3 select lines because 2 to the power 3 equals 8, right? So the truth table will have 3 select lines, that's the S2, S1, S0, corresponding to one of the 8 inputs. For example, so when the S2, S1, and S0 are all 0, input I0 is routed to the output Y. And when the select lines are 0, 1, 0, then input I2 is selected. So for every possible 3-bit combination, the corresponding input is connected to the output. Alright, so without wasting my time, let's go to the circuit design using the logic gate of the 8-to-1 multiplexer. So to build an 8-to-1 multiplexer using basic logic gate, we are going to follow a particular structure. So you are going to need 8 AND gates. 8 AND gates. So we take our AND gate. Now we change the number of inputs of the AND gate to 4. So we have 4. And then since we are going to need 8 AND gates, I'm going to just copy and paste 8 times. Right, so this is my second one, my third one, my fourth one, my fifth one, my sixth one, my seventh one, and the final one. All right, so as we said, we need 8 AND gates, 8 AND gates. Now each AND gate will take one data input and a unique combination of select lines as the control. So let's introduce our 8 inputs. So this is our first input. This is our second input. This is our third input. This is our fourth input. This is our fifth input. This is our sixth input. And then so this is our first, second, third input, fourth input, fifth input, sixth input, seventh input, and then we have our final input. Alright, so with our input lines ready, we are going to combine all the outputs of all these AND gates using an 8 input OR gate. An 8 input OR gate. So we are going to combine all these 8 AND gates using an 8 input OR gate. So we have our 8 input OR gate here. We change the number of input to 8, and then we connect all our AND gate to our OR gate. Right, so these are our first input. Right, so followed by our second input. Then our third input. Then we have our fourth. Then we have our fifth input. We have our sixth input. We have our seventh input. And then our final input. Alright, so all we routed to an output Y. Very good. Alright, so now we are going to need our select lines, right? So as we said, for every possible 3-bit combination, the corresponding input is connected to the output. So let's construct our 3 select line. So this is our first select line. This is our second select line. And then we have our third select line. Right? Alright. So we are also going to need a NOT gate to generate the complemented versions of the select lines, since the logic expression includes both true and complemented forms. So the 3 combinations that we are going to look at, all the 3 possible combinations will have some true and complemented forms, right? So we are going to need some NOT gate for each select line. So let's go ahead and construct the NOT gate for each select line. So tap from here and then stretch it. Tap from here and then stretch it. And then tap from here and then stretch it. Alright, so we are now set and ready to build our multiplexer. So we are going to use the truth table for the 3 select lines, right? We are going to use the truth table. So when you do the truth table, you are going to see that the first select line will have 4 zeros. That's 0 0 0 0 1 1 1 1. Our second select line will have 0 0 1 1 0 0 1 1. and then our third select line will have 0 1 0 1 0 1 0 1, right? So the first combination of our three select lines will be 0 0 0. All right, so we are going to have uh, 0 0 0. So this is our first combination, and then our second combination we are going to have 0 1 0, since the input starts from I0 to I7. So we are just converting the 0 to 7 into binary, right? Where we have three select lines. So 0 0 0 standing for 0, 0 0 1 for 1, 0 1 0 for input 2, 0 1 1 for input 3, 1 0 0 for input 4, 1 0 1 for input 5, 1 1 0 for input 6, and 1 1 1 for input 7. So we just completed the 0 0 0 for input 0. So let's move on to input 1, where our combination is 0 0 1. Right. So we have 0 0 and then 1. Right, so what we are doing is the complemented form is the 0, and the uncomplemented form or the true form is the 1. All right, so anytime there's a 1, we use the true form. Anytime there's a 0, we use the complemented form. All right, so for our input 3, for our input 2, we are going to use 0 1 0 0 1 0. So we are going to have so 0 1 and then 0. So that's for input 3. Then we'll move on to, that's for input 2. Then move on to input 3. So for input 3, we have 0 1 1. So this is input 3. So we have 0 1 1. So we have 0 1 1. Well, then for input 4, we have 1 0 0. So for input 4, we have 1 0 0. All right, then for input 5, we have 1 0 1. So for input 5, we have 1 0 1. So we have 1 0 1. Right, then we move to input 6. For input 6, we have 1 1 0. So for input 6, we have 1 1 0. So for input 6, we have 1 1 and then 0. All right, and then for our final input, we have 1 1 1. So we have 1 1 and then 1. All right, so just trying to make my circuit diagram beautiful. All right, right, so this is our final 8 to 1 multiplexer. So let's test this and see how this multiplexer will work. All right, so we click here, we simulate, and then now when it is 000, this is our first input, so this is input I0, right? So it's only input I0 which will work. The other ones will not work. All the other inputs will not work. All the other inputs will not work. Then when it is 001, then it is only input I0, I1 which works. So only the second input works. So the first input does not work. Only the second input works. So only the second input works. The third input does not work. The fourth one, the fifth one, the sixth one, the seventh one, the last one also do not work. Alright, so when the select line is 010, so 010, then only the input I2 works. So only the third input works. So the first input does not work, the second input does not work, but the third input works. The third input works because our select line is now in a combination of 010. The fourth input does not work, the fifth input does not work, the sixth input does not work, the seventh input does not work. So I'll go ahead and test for the rest of the combinations, right? So for this one does not work, this one does not work, this one does not work, but this one works, right? So this is input I3. So when the select combination is 011, our input I3 is the only one that actually works. The rest of them do not work. Alright, so when the select line is 111, can you tell me which of the input is going to work? Alright, so you guess right. So that's the final one. That's the input 7. So you can see that when we click on it, it works, but the other ones will not work. Alright, so this brings us to the end of our presentation on how to build an 8-to-1 multiplexer. Thank you.